Hello, Svelte people. This is the Svelte Society for developers who are new to Svelte and want to learn to do other stuff good too. Did you know that there's more to life than making really ridiculously good looking apps? You can also make them with a lot less code. In this talk, we're going to start from complete scratch, and then I'll show you how to build an app like this, where there's animations involved, there's data fetching, there's switching of orders, and then there's multiple data interaction paradigms. We're going to cover fetching on mount. We're going to cover Svelte's if and await and other syntaxes. We're going to cover fetching on user interaction like button clicks. We're going to cover promise swapping. That's a completely made up term. Svelte class binding, stores, component reactivity, and animations. It's going to be a fun ride, so let's get started. We'll start with the minimal Svelte app, which is just HTML markup. And I've also pre-prepared a mock API backend. This just reads a JSON blob and then exports a asynchronous function that returns a promise. This promise has some mock delay set into it that we can tweak if we want. And it just returns one of the records that we have from the JSON blob. So this basically just mocks an API with some latency. So now let's actually try to bring this data and show it in our app on the right. So here we'll start to add some JavaScript, and we're going to start importing it. I know the file structure already, so I can just say import fetch data from .fetch data. And now we can actually call that asynchronous function, and then we can set it to something. We kind of need to set it to something to show up on the screen, but let's actually just see it show up in the console log over here. Yep, it shows up in the console log. So now we actually need to show up on screen. So we'll just say something like let data is blank, and when this data comes back in here, we'll assign that to our data variable, and then we'll show a data variable in, for example, like a pre-tag. I'm going to JSON format it because it's just a nice way to show data. Okay, there was the brief undefined period, but now we have all the details of Spider-Man, which is the first and most popular character of Stan Lee. So we got data to show up on screen, but it's still kind of unsatisfactory because while we're still loading, there's this ugly undefined here. So we probably want to manage it by showing a placeholder or some sort of fallback. I have a spinner component over here, which I can just import spinner from /spinner. And now I can also start using one of the Svelte directives. So here I'm going to use if data is truthy, then we're going to show that pre-tag. And if not, we're going to show something else. And we'll add the spinner component in the else block. So at least something nice shows up while we load data. There's still one more problem with our solution so far, which is that we haven't really handled any errors. We can simulate this with our mock API by simply just doing a .then and then throwing throw new error. Oops. And I think we just say throw error oops, and then our app just never resolves. So this is an important case to catch, and in order to handle this, we actually need to add a second variable, like an error variable, and then we'll say a .catch error, and then we'll assign e to that error, and then we'll handle it down in the template. We can actually do a nested if. So this is handy if you really want full custom logic. And we'll just say if there's an error, show something like a block quote, for example, and we'll show the error. And then, but actually the better way, because these are all mutually exclusive, is to do an if and an else if pattern. And the VS Code extension that I'm using actually just auto formatted for me. So that's very, very nice. Good. So we're now handling both error cases, success cases, as well as loading states. So that's a fair amount of boilerplate for fetching data. Let's see if we can do any better. Svelte actually offers really good syntax for unrolling the 3 states of a promise. And that's essentially what we've been doing manually, but we can now use Svelte syntax for it. So I'm going to replace all of this stuff, and I'm going to declare a promise variable, and I'm going to assign it to the fetch data call that we have here. And I'm just going to completely ignore everything else that we have. Down in the templates, I'm actually going to replace the if and else if syntax that we've been using, and we're going to start using the await syntax, and we can await on the promise that we've just constructed above. The most important part of the await syntax is the then, because that's when you get actual data. I can name it data down here. Notice I don't have a data variable up there anymore. I can just name it whatever I want, but I'm just going to call it data. And now I can just steal from my pre-existing solution. Let's actually see something show up on screen. Good. So something's showing up, but we also have to replace everything else with what we planned to do. So let's actually unroll this. My VS Code extension has been too helpful. Then data. So let's actually have something in the loading section. So here is where we put in the placeholder when the promise is waiting for something to happen. And then we can also declare a catch down in here. And we can just put in all that stuff. So basically the same amount of code down in the bottom, but a lot less declarations up in the script section because this is so boilerplate. So the await syntax turns a lot of imperative data fetching and state management code into declarative nice syntax where it's easy to extend for the 3 different states. It's totally optional, but most of the time you're going to want to use this instead of rolling your own data fetching methods. So far we've been loading data based on component mounting. But obviously, most of the time you're going to want to actually load data upon user interaction. So let's actually put in a button and try to load when we click the button. So I'll put a button in the control section I have over here. And I'll just say this is for the next character, for example. And I'll declare onClick with a handle click function. And we'll just go ahead and wrap that promise setting into the handle click function. So here's a key feature of the way that the await syntax handles the promise setting. This every time the promise is set, the await reruns itself. So let's save it and see what happens. So as of right now, the promise is null. So nothing has been set and therefore nothing is displayed. This may or may not be desired behavior, but we can also click next and then it fetches that data by setting that promise. And then we get back our original behavior. If we wanted to load that data immediately on component mount, we can actually just set it when we declare the variable. Now let's actually modify our code to cycle through some of the characters. So I can declare a variable called index, and I'll just set it to 0 for the start. And every time I click the next button, I can increment that. So Svelte really kind of just supports mutability, so we can just go ahead and increment that. And that should return a new character every time. So let's save it and see what happens. So at first we should get Spider-Man, and then we click next and it clears it and then we get Iron Man. So this data fetching is very nice, but the problem is it always wipes away the old data and then waits to fetch the new data. And we may not actually want this. We may want to actually show stale data while waiting for the next thing, and then we can just show like a loading indicator while we obviously know that something is going on. One way to handle this is promise swapping. So let's actually see how this works. We'll declare a second promise, say promise 2, and we'll initially assign to promise 2 instead of promise 1. Then we'll just chain a .then onto that asynchronous function, and we'll receive that data and we'll return that data. So we're basically just intercepting, resolving the promise. Then we'll just swap the promises once the original promise is done. So let's see what effect this has. So now when I load my app, it fetches that data, and then I click next, and it still loads in the background, and only once it's loaded, then it just swaps it out. We might actually still want to see some loading indicator, so we can actually use a second await. So let's actually do one here, and now we'll just await on promise 2, and we'll just say, for example, we'll just put a spinner here if we're loading, and we'll just close that await. The VS Code extension that I'm using currently auto formats this with a then block, which I don't really need, but it's something that we can resolve on our own. So the net result of this is that now I have got two promises that I'm swapping. And whenever I click next, I can show a loading indicator. And then when it resolves, it goes away. And then I have the new data over here. So it's very clear at each stage whether data is in flight or the currently requested data is showing. All right, so let's say this still isn't good enough for you. You actually want to, for example, add a class to indicate that this is stale data. So it's not enough to just show the loader, but you actually want to modify this DOM node to show that it's stale. Unfortunately, there's no way to just unwrap that promise state. Maybe Svelte can do that in future, but for now, we're going to have to just manually track it. So we'll just say something like let stale equals to false, and this can be set to true whenever we click handle click. So now we know it's stale, and then while the promise is out there, it's still stale. And then once the promise resolves and we get back our data, we can set the stale to false. We can actually use, so I have some pre-made CSS, and if class equals to stale, then it's going to show as like a grayed out, format like this. So our task is to just toggle this on and off. A simple naive solution would be to basically just do this, if stale, and stale, and that would be fine. So here we can just click next, and then it just grays out a little bit, and then it's very obvious that it's stale. But we can actually use some nice Svelte shorthand. So we can say Svelte stale equals to stale, like this. And this actually changed. So for example, if I had some other class name that I wanted to make dynamic, I can also just keep adding it on foo and then bar, whatever. And these would all just chain into one big class. So that's a very useful thing to note. But for our purposes, we just want to add stale and toggle the class of stale on and off based on the variable stale. Because this is just a repeat, Svelte has a nice shorthand. Let's see if I save it. Yep, it just truncates to that. So it just says class is bound to stale for this variable, for this DOM node. So now we've implemented stale state tracking as a standalone variable separate from the promise. And now we can actually see very, very visually that when our data is stale and when we're still fetching it. Of course, this is starting to look like a lot. And we still actually have not handled one kind of fringe, but also very common issue, which is the memory leak when, let's say, this component unmounts and we're still fetching that data, and then we try to resolve that, right? So if you're familiar with other frameworks, for example, React, you have the same exact problem. Like you try to set state on an unmounted component, you get an error. Same thing is the issue for Svelte, and we kind of need to handle it if we want to write perfect data fetching code. For more investigation into this issue, I'd definitely check out Ryan's notes on this, because he's actually investigated what exactly still remains when the components are mounted while the promise is still pending. So some things are taken care of, like reactive assignments, but some things like events and callbacks are not. And so you can actually check his repo for checking through all the different small issues that might result. And for our purposes, the main naive way to handle this is to hook into the onDestroy lifecycle method of Svelte. So we'll just say onDestroy from Svelte. And we'll state, for example, is mounted. We'll declare an is mounted variable, and we'll say it's true. And if onDestroy, we'll set it to false. Equals to false. So now before we call any callbacks, we'll have to say something like if is mounted is false, then just return. So by doing this, we actually don't trigger any other updates of state. So this does look like a lot. And basically the problems arise when we try to locate all the state inside of the component. If we actually start to move it out into a store, This might look a lot simpler. So let's actually see what that looks like. It turns out I can reduce a lot of this code and all the accidental bugs to do with component unmounting by moving the state management out of the component level and into a separate store. So let's actually see how Svelte stores work. I have a separate talk on these if you're interested, but I'm just going to fast forward through. We're going to import writable from Svelte store because we want to create writable stores. We're going to have a data store with an initial value of undefined, and then we're going to have a fetch state store with an initial string of initial. You can obviously implement both of these as a one store with an object with tracking both states, but this is just the way that I figured it out. Then we're going to wrap the fetch data API call into a custom method, and this is driven by our domain design. So for us, we're going to say that we're going to set the fetch state to loading, and then we're going to fetch that data, and then set the data store, and also set our fetch state to done. And for the purposes of initial load, we can call that function so that it's not going to be undefined at the beginning. So let's actually see how we can implement this and what it saves for us in terms of amount of code. So over in our main app, we can replace our initial fetch data call with data, fetch state, and the new custom get new character method. So now we actually don't need a lot of these promise tracking because now we're managing the state in a separate store. And we'll delete all this code. When we handle click, we only get new character and we increment index like we did before. And we no longer need to track whether the component is mounted or not. So because we're no longer dealing with promises at the app level or at the component level, we don't actually need the await syntax here. So for example, we can just track fetch state and we can use ifs. When you access Svelte store values, you have to use the special sugar syntax of and adding $1 in front of it. And so for us here, we can just say something like if fetch state triple equals to loading, then we'll show a spinner. Down below, we'll say something like if data is empty, so we can access the data store as well. So data is undefined, then we'll show a spinner. Else, we have that data, and then we can access that data store down in the JSON. And finally, we can toggle that still class according to the fetch state. There's multiple ways to do it. I'm just going to choose, for example, if it's not done, then call it stale. All right, so let's see how this works. If we click next, it stales out, and then it shows the new value. Click next, stales out, shows new value. So that's a lot less code, and it doesn't have memory leaks, or rather it has a very containable memory leak that we can track on an app level. So these are not equivalent solutions, but these are just multiple methods to do the same thing that is worth being in your arsenal as you use Svelte. Okay, so we've explored a lot of data fetching paradigms at the component level. I want to step up one level of abstraction and actually explore coordinating multiple components fetching data. So let's actually extract our code into a standalone card component. I prepared some of the templates over here, but basically we're just going to extract all of this stuff, and we'll keep the index selection at the app level. So instead of getting new character when we handle click, we were just going to bump the value of index. And also we're going to start importing the card component. So card from /card, and then down in here, we're just going to get rid of all of this. You understand, like, how to implement it if you need to. But here we're just going to say card index of index. And obviously the shorthand for this in Svelte is that it just collapses into a single curly brace pair. Over in card.svelte, we need to take the same imports that we had. We're going to declare a prop of index, and this will be the index that's passed in from the app level. And then we're just going to do a very simple get new character call on component mount. Obviously, there's a lot of ways separately that you can do that. I do need to fix a little mistake, card.svelte, because Rollup doesn't know about the extension. And now we have a nice card component loading. I did make one mistake here, which I wanted to point out because that's a key part of this. So when I click next, it's going to increment index by 1. And that should also re-render the card component with the new index. But it doesn't, and that's a interesting bug. It's not really a bug because that's something I planned. Whenever you're dealing with components and you want to react to changes in props, you need to declare statements as reactive. So for example, here we did an initial data fetch. Svelte has no way of knowing that the component changed and you want to refetch. So by default, it doesn't rerun code, right? Whereas React reruns code all the time. So in order to turn it reactive, we just add a $sign here. So now whenever we click next, it's going to start loading the next page. So you can see my app code looks a lot cleaner than it did before. Some of it is because we reduced our requirements, but then also we've just abstracted away parts of the logic into a separate component. So components, of course, very good at doing this. You don't just have to pass data, you can also pass functions, and you can also pass up events. So let's have a demonstration of what I mean. Over here, I have a button component. It exposes a handler prop and applies it on its own onClick event that's nested inside of that label. So in my app, I can import that button, and I'm going to upgrade this to the capital B button and call this a handler. And that should work exactly the same. I'm also going to take the advantage of inlining this function because I don't really need it up there. So I'll just say index plus plus. Awesome. Great, so that works. But a nice trick of Svelte is that you can actually forward events. So in the button code, instead of explicitly declaring a prop, I can just delete that and just say that I'm going to forward the onClick event. So even though it's nested within a label, I can still forward an onClick event. And here, instead of the handler prop, I can just say onClick. And this should just work exactly the same. So that forms a very nice abstraction, and you don't really care how nested that onClick event is. We'll now introduce a new variable to show the number of characters that we're going to display at the same time. So I think by default, we'll just go with 3. And then we'll add a control for that to our app. And finally, we want to generate an array out of those numbers. It's going to be reactive to the values of index and len. And I'm just going to paste that in because the logic doesn't really matter. So now we're going to use Svelte's each syntax. So it goes each item in array as ID, for example. And then we're going to close that in here. And now we can feed IDX equals to ID. So now as you can see on the right in the browser, we've actually started fetching 3 of the exact same character. This is because we've tied our card component to a single data store. So it's just drawing from that same data store and setting that same data store every time. We need these to work independently. So we're going to have to refactor the store. It's a pretty simple operation. For the sake of simplicity, I'm going to drop some of the requirements that we had before. But basically, we turn the writable store into an object instead of a single unit, and then we set by the index of the character. So now we only have 2 exports, a data store of all the characters, as well as a get character function. So we can rename this. And now we'll just call get character whenever we mount that component, and we'll drop the requirement for fetch state. And we'll just say data index. And that should generate a nice list of non-duplicate. As a bonus, because my data lives outside of my component, these are all basically cached. So for example, if I hit next and I increment the ID, the data for the components where I've already pulled from my API is cached. Obviously, you have to figure out cache invalidation yourself, but that's the rough idea of having a standalone independent data store separate from your component state. So this is great, but it kind of looks a little bit janky still. It doesn't look that fluid. And there's one final touch that we can make this really pop. We're going to import flip from svelte/animate, and then we're going to go down to our card, and we're going to give a wrapper component, div animate flip, and wrap this div around the card. Now for Svelte animations, they must be on natural DOM nodes, not Svelte components. and they must operate within a keyed each block. A keyed each block basically tells Svelte how to assign a key for each iteration of its loop. So here we're just going to assign the exact same key of ID that we pull from the array. Now it might look like nothing's changed, but when I click next, it actually smoothly animates up the next cards, which is very nice. And when I zoom out a little bit, I can add more cards, and I can delete more cards. If this animation feels too long to you, you can customize the duration, as well as a bunch of other really handy variables like the easing function. So here it moves a little bit quicker, which is something that may be preferable to you. One final feature to show off the flipping. So let's implement a is ascending Boolean. So we'll say this is false, for example. I don't really know what the order is, but it doesn't really matter. And so I'm going to let the array stand alone as an independent variable. I can say something like if is ascending, then array.reverse. And finally, I can add a control for that down in my control section. So now whenever I click is ascending, it has a nice switch to that. All right, so that is a grand world tour of data fetching in Svelte. I have one final tip for you, which will really enhance user experience, especially when they start on your app for the first time. A lot of people forget to design their empty states. So for example, here I have an each over an array, and usually this array has something in it, but let's say it has nothing. There actually is Svelte syntax for that, and it's the else tag. So let's actually see what this looks like. So now if I can decrement the show and it goes to 0 and I still have something that I can show to users. So yep, that's all the data fetching knowledge that I have. If you have other things that you want to contribute or you want to learn more about Svelte, come over to the recipes MVP. We're collecting a bunch of community recipes for stuff like this, applied knowledge for using Svelte on real life situations. Thanks very much, and I hope you stick around for the rest of the talks.